It starts as a rough piece of scrap steel, but with careful machining, it will become a precision split nut. Then it is cut straight in half. Every surface has to stay within a tight tolerance. So when the two halves come back together, the nut can still lock onto the threaded shaft. Making a nut is simple. Keeping it accurate after cutting it apart is the real challenge. This is called a split nut or a half nut. It is designed to match a threaded shaft with a diameter of 33.99 millimeters. The outside diameter has to match the body of the nut exactly, but this steel block is too tall for the machine setup, so the first step is to remove the extra material. With this machine tool, the work can begin at a controlled angle. First comes the outer surface. After years of exposure, the steel has a heavy layer of oxidation. If that layer stays on, it can affect the final accuracy. The plan is simple. Shave off about 0.5 millimeter. That reveals clean alloy underneath. A split nut has holes a standard nut does not need. There are 4 of them. Look at these 2 holes here. They sit perfectly on one side. Their position and depth must be especially accurate. Drilling them correctly is critical. The remaining internal thread will help the split nut clamp tightly. Now you can see why it is called a split nut. The 2 halves are held by screws, but these screws are mainly there to hold the 2 halves together. This design cannot reach the strength of a solid hex nut. Next, it is cut in half. From this point on, every step becomes more delicate. The saw blade itself is about 0.5 millimeter wide. That means some metal is lost during the cut. So how do we make up for that? How do we restore the original accuracy? A level gauge checks the flatness of the steel. Once the reading is brought back to 0, the grinding tool above can begin removing material. Think of this as precision finishing. After the cut, the surface must be ground for about half an hour. Only the high spots are removed. The cut is extremely light. Watch the surface closely. So what is he really grinding? Not much at all. The surface is already nearly flawless. And this is only one pass. It takes half an hour to get here. There are 5 more passes to go. When both halves are included, that means at least 10 passes. The result is easy to see. The finish is almost mirror smooth. At the joint, the 2 surfaces meet almost perfectly. There's barely a visible seam. When the craftsman tightens both sides with screws, the separated parts come back into perfect alignment. But at this tolerance, even tiny errors still matter. So after it is secured in the chuck, another 0.5 millimeter is machined away. No matter how uneven the front was, the remaining surface is now clean. Check it by hand or with a gauge, and the error is almost impossible to find. Now we move to the internal thread. Before threading, the craftsman uses a drill bit to open the inside wall. The hole must be round. From this point forward, he works the tool back and forth. Slowly, the thread begins to take shape. Then come 5 more finishing cuts. The chips stay under control. Only then can the thrust needle bearing fit into the groove. At this stage, he relies on touch to confirm the fit. A plain split nut alone would not be enough for long-term use. So, he machines several more holes around the outside. When a handle rod is inserted, both hands can apply more force. With all these holes combined, there are at least 8. It is tougher to make than it looks. Here's the important part. The smaller holes secure the handle rod. The 4 larger holes on top are used for the clamping screws to make rotation easier. He also machines grooves into the bottom. This allows bearings to be installed on both sides. That reduces effort when the nut turns. Now he forms the outside gripping surface. A hex nut can be tightened with a wrench. In the same way, this part needs a surface that can be gripped. Otherwise, oily hands on a smooth surface would never give enough control. After these details are finished, the main shape is complete. Now we can see the split nut clearly. Can it be used right away? Not yet. At this point, it is still only a rough workpiece. On the part itself, you can see the thread teeth and pitch. You can also see the gap between the shaft and the internal thread. What it still needs is strength. So, the craftsman places a steel plate inside the furnace. The nut will be heated for 30 minutes at a steady temperature. This step is similar to quenching. Its purpose is to increase metal strength after hours of machining. The structure needs to be stabilized. Then it is cooled in oil. Once it cools, the part reaches the required hardness. This happens quickly. It takes about 2 to 3 minutes. On the left is the part before quenching. On the right is after quenching. It is darker, harder, and more durable. Next, grease is applied. Then 2 thrust needle bearings are installed. One goes above, and the other goes below the nut. The groove fits around the bearing perfectly. So now, the installation is much easier than it would normally be. Without this split design, the inner shaft would have to be removed. This saves a lot of work. Then he takes a wrench and tightens the special screws on top. With a small turn, the rod can move up or down freely. So how is this device actually used? First, he places a large flat roller on one side of the setup. Then he tightens the nut. A smaller shaped roller is placed on the opposite side. Next, he turns it to the correct height. Once it is mounted, the 2 rollers are brought close together. Then a flat steel plate is inserted. Under the pressure of the 2 rollers, he pulls the plate back and forth. You can already see the metal beginning to deform as the passes continue. He inserts a steel rod through the center. When the pressure reaches its highest point, the plate begins to bend much more quickly. So even though this is only a split nut, its accuracy determines how well it works. Keeping it stable is the most important part of the job.